punctual attendance to part 2 in a series of webinars that X-Rite Pantone has put together. My name is Jim Luttrell. I'm the Field Marketing Manager for X-Rite Pantone in the Americas, and we're very happy to welcome you to our webinar today. As you see on the screen, what we're going to be discussing is a matter that is of direct interest to grand format printers and the topic of G7 for grand format printers. So we're very happy to sponsor this webinar. As you are well aware, X-Rite Pantone is a leader in color management technologies, and we're going to get to the next slide here. We have a very strong footprint, obviously, in the commercial print space, but the need for color management in wide format and grand format is becoming greater and greater. So we're very happy to present this presentation to you. We're very happy to have with us Dan Reid. Dan is the founder of RPimaging. He is one of the early adopters of G7, and he is certified by ID Alliance. And his close work with wide format and grand format printers puts him in a very unique position to talk to us on this theme. So first of all, Dan, we welcome you to our webinar.
Thank you. Thanks, Jim.
And before we start, just a couple of housekeeping notes. You'll notice that you're in mute mode right now. We have a nice attendance today. We're happy that you're here. If you have any questions, just feel free to type them in that panel over there on the right, and you'll be able to send in your questions. And at the end, we'll have a Q&A session where we can discuss those with you. So without any further ado, Dan, we look forward to your presentation.
Thanks, Jim. So in part 1, we kind of discussed printer calibration, and up I have on the screen is the slides and the recorded webinar if you did not attend that. I think Jim can post those into the control panel there, so you can click on the links instead of trying to write them down. This webinar is also being recorded, so we'll be able to send a link to that as long as with the slide deck later on. So today we're going to be, sorry, Jim?
Oh, just to let them know that in the chat section of that panel, you'll see 2 links of the first webinar. So the slides you can download, or you can actually see a recording later on of the first webinar. So it's all there posted on your chat section of your panel.
Cool. Thanks, Jim. So our agenda today is we're going to do a quick poll. We're going to go through some of the background and myths of G7, ways that you can achieve the G7 compliance, and tools that are available, some tips that I have for you, and then the all-important Q&A section at the end of this. So why don't we launch our first poll question there, Jim?
Okay, very good. The question on the first poll is, have you implemented G7 calibration at your business? So if you could just tell us yes or no quickly, it'll give us an idea of where we're at. And what I'll do in a second is I'll close the poll and I'll share the results. So 50-50, Dan. Half the audience has, and half the audience has not.
Oh, interesting. Okay. All righty. Well, the follow-up of that, for the people that say they haven't, what are some of the reasons that have stopped you from doing so?
Very good. So you see the question there. So they got you got 4 different possibilities you can choose. If you've not implemented G7, it's either too complicated, too expensive, not enough requests from customers, or you don't see the benefit. So if you have a chance to weigh in on that, that would be helpful to us as well, as we understand. So of those 50% now that have not, so what we have is 50% of those, Dan, have said that they haven't had enough requests from customers. Number 2 is it's too expensive, and number 3 on the list is they don't see the benefit. Too complicated was not chosen by anyone. So thank you very much.
The first one was that customers are not requesting it or asking for it.
That's right. Yeah.
Okay. Okay, good. Well, thanks for the feedback, folks. So I'm going to jump right into the presentation. Without a doubt, all of our files usually come in a couple different ways. They're usually either RGB, CMYK, or they could be just defined as a spot color. But, with an RGB file, as we all know, that if you have equal amounts of red, green, blue, you're going to end up with neutrals. And, files that come in as CMYK, if someone doesn't know anything about anything, they're probably converting and using web-coded SWOP 2. Or if they do know what they're doing, maybe they'll be using the GRACOL 2006 separation. But as you know, the US web-coded SWOP V2 is not based upon G7, whereas the GRACOL profile is based upon G7. So, you got to be careful on this. When you do taking files, you want to double check what color space they're in and define, if you want to change that or if you're going to honor that. But actually, if you swap out GRACOL, you'll find out that, swap out the US web coded for GRACOL, you'll see that you don't get too much of a color shift. I was pretty amazed when I started seeing this back in, 2006, 2007, where there is a slight change there. I don't know if you're seeing it across on the presentation, but if you look at the babies, you can see little subtle differences there, but not too radical. So you could, use a GRACOL profile as your source and just ignore the US web coded, and you would get pretty good results. So kudos to the folks that came up with this to be able to take all those old separations that we've done for years and years and years and not have to re-separate it, just assign a new profile, and you get a very similar color balance. Not perfect, but, pretty good. If I enlarge a portion of it, you may be able to see a little bit better if you look at the, the purples and things of that sort, or maybe look at the reds. You can see how things have slightly changed there. But again, the color balance is pretty close between the two. It's not radically off. It's not, something that you would be very surprised by. So, with RGB files, it's pretty easy to make neutrals, but in CMYK, we've kind of come to accept that for a midtone, we use 50-40-40 for, let's say a quarter tone. I think it's 25-18-18 or 19-19, if I remember correctly. So there's some common gray balance triplets that we've come up with, and these are what, we target for when we're doing a G7. And the G7 process, of course, was used to build the GRACOL and US web coded 2006 versions of the profile. So there's actually two SWOP G7 profiles. There's one that's a number 3 paper and one that's a number 5. Most people will be using a number 3. Very, very rarely will you find someone using a SWOP 5. So one of the things that people talk about is that, yes, neutrals are important, but one of the things that they lose sight of, especially with the G7, is the method that they use to maintain a consistent visual contrast. And this is relative to your substrate. So what happens here is that we try to maintain a neutral density minus paper and have that consistent. So this way, as we move from different substrates, we have the same mid-tone contrast. And that's a key element that you don't find in some of the other methods out there for creating gray balance on press, is that they will gray balance, but they don't necessarily address the mid-tone contrast. And that's why they'll have nice neutrals, but it will still look visually different because some prints look contrastier or lower contrast than other prints, depending upon the media. So kind of a quick history of the G7. It was actually, I think, formally introduced in 2006. Obviously, they had been working on it before 2006, but they fully, put out the program and started getting people certified starting around 2006. I went to one of the first or second classes that they had, and obviously they were still working out the kinks on that. But I've been doing the G7, implementations for, I guess, what's that now, 6 years now, and have worked with many different printing technologies, going from offset litho to screen to flexo to grand formats. I mean, it's pretty amazing how well this process works across different printing technologies. And at first they didn't want to really kind of oversell it, so they kind of undersold it and let's move it out to different printing technologies and see what the experiences are and get feedback. And they were pleasantly surprised that a lot of printing technologies were greatly improved by using the G7 process. So you'll find a lot of different industries that are using it. A lot of the grand format rips today support importing a G7 correction. Some have a method that uses color references to get there, and some have actually are just coming out with built-in tools that will allow you to create your G7 without having to use external software to do so. So some of the myths that you will find out there that I run into is that G7 is not a substitute for color management. It never was designed for doing so. It was obviously designed for litho originally, and so people think from that point is that it's only applicable to litho. But if you are thinking, outside here of the box, all the separations are done or are coming in as CMYK are pretty much designed for either SWOP or GRACOL, so a printing press. So it's a litho, and so if we can get our printing devices to have similar characteristics, this makes the whole process of color management go a lot easier. So what I mean is that if you align that, if you have a color separation that has a 50-40-40, and that comes out correctly on different printing technologies with having the same gray balance and the same visual contrast, that's going to make the profiling process of converting from one source to a destination space a lot easier. Also, a lot of people think that you can just build profiles and the profiles will get you there. And yes, they will to a certain extent, but there's things that they can't do. And so that's why I tend to think that, yes, you can use color management and ICC profiles to achieve G7 and to achieve a color match, but you're really not getting the full benefit because, if you need to do a relinearization or if you need to come back to certain things, you're going to have to potentially update and make a new profile if your process is not stable enough. So ICC profiles, as you may remember, are not designed to fix things. They're not designed to say, hey, if you've got a color bias or you've got poor calibration, just build a profile and it's going to fix it for you. It does. It works pretty well. I'm always pleasantly surprised at how well it's able to compensate, but that's not really the goal of the ICC profile. The ICC profile is designed to characterize that print process, to say this is the range of colors that's going on, not to basically compensate and try to fix things. So when people try to get G7 via color reference, what's happening is that they are taking their source, which would be a GRACOL or a SWOP, and then they're making a proofer profile or a output profile, and they're trying to see by that color match, are we able to meet within the G7 metrics? So typically I find the profiles that people build just don't have enough samples in them. They'll use 1,600 patches or something of that sort, and there's just not enough samples to give enough accuracy. And their tables in their profiles don't usually are high enough in resolution, so the accuracy of doing that match is not very is usually not as good as it could be. So you can bump up the table resolution size. It's going to make a bigger ICC profile, and at some points it was a problem, but nowadays it's not so much of a problem. But not all profiling packages or RIPs allow you to change the table resolution or change how many samples you can do through the profile. So what happens here is if you don't have enough samples or if your resolution is not high enough, you may need to do some tweaking. You may need to do some editing of that match. And this is kind of a back and forth trial and error type of thing. So it's very time consuming. It's kind of subjective. And so we tend to try to shy away from that because that really, revolves around one person or a group of people. And that makes it so they're the kind of the key elements of that. It's better to use devices like spectrophotometers and things of that sort and measurements to make it more objective. And that way, multiple people can always follow the same process instead of having one master person who's there just to do the tunings and things of that sort. So when it comes to core calibration, of course, no one would want to say, hey, just throw out, the calibration, just build a profile, and that's going to, fix the color balance. No one does that. Everyone knows that, hey, I got to do some calibration, optimize my ink limits and all that sort of stuff before I build the profile. So you would never do that, as a normal method. The profile is not going to automatically redistribute the tones to make a nice linearization. Just that doesn't happen with the thing. And so conversely, it also, is not designed to kind of remove any color bias. So if you print out your profiling chart and it's got a bluish cast to it, that profile is going to represent that bluish cast exactly because that's what it's designed to do. It's not really designed to say, oh, there's a bluish cast. Let me now remove that. So anytime when I do separation, I remove that blue cast, which it does, but that's not really what the job of the profiling software is. So you get into now kind of gray balance and black generation settings, and what this is kind of like, how quickly you're ramping up black and pulling out CMY, or the opposite, where you're basically saying, hey, let's push out more CMY and reduce the black. How are we going to build that neutral? And again, there's just not usually enough samples that are in the profiling charts that are 1600 or some of the ones that we have come to use like ITH-74 or ECI 2002. They work very well in a printing press because a printing press is a lot more well behaved than a grand format printing device. So they can use less samples and be okay, but when it comes to these printing technologies that are non-litho, and you're going to need to have a lot more samples. So one of the nice things about the X-Rite I1 profiler is that you can determine how many samples you want to do, and you can go further and actually add more samples and optimization to get you tighter color matching in certain areas. So, if the chart that they're using, let's say, is an ECI 2002 or an ITH-74 in the RIP product, there's not going to be enough samples there to do that. And so some of the more proofing RIPs, what they will do is that they will kind of print out the chart again, measure it, and then do kind of a 3D lab type of correction, and then print it out again and remeasure, and it's kind of an iterative process. And that works, but it's just very time consuming. So, here's a typical ECI 2002 chart that I grabbed to make it really easy to see. This one is only got 1,500 patches in it, but you can see that there's some neutrals in there, but there's not a heck of a lot of samples. There's some pastels, there's things of that sort, and so that's what it's got to use to kind of figure out its black generation and gray balance. So the black generation, as I said, kind of is how you're building your gray. Here's a screen capture of the I1 Profiler software, and I've clicked on the little icon on the top left there to show you the curve. So this shows you how this black curve is being generated. These were just the default settings to show you. But notice that this doesn't really kind of address kind of the look of the print. So even though you create your profile and you're doing your black generations, you got your neutrals, it doesn't kind of address the visual contrast aspect of it. So when people use G7 via color reference, you can do this, but it's very tricky because you've got a lot of medias. I mean, typically you've got dozens of medias that you've got to go through and create profiles and compensate and all that sort of stuff. And there's just, it's not very practical. So by using the G7 method, you can, get those a little bit more in line beforehand. And so as things drift, you can use the G7 method to recalibrate, which will get you back to where your profile was built originally, based upon a gray balance. Now, if you use two profiles and you get your color match, you may find that passes your G7 qualification tolerances, but like I said, it's not going to give you the ability to get back there again very easily unless there's some kind of G7 or gray balance relinearization method. Most of the relinearization methods are not based upon grays. They're just based upon each of the cyan, magenta, and yellow, black, and looking at the dot gains or how the linearization is. It's nice smooth gradients and things of that sort. But they're not adding those together and trying to find out, what does the gray balance look like? Which is, in my opinion, a little bit more important than just having smooth linear gradients. So, the references that we're using right now, GRACOL and SWOP, were obviously designed for different printing processes in gray and format. And sometimes the medias that we use in gray and format are provided with a larger color space, but more likely than not, a lot of times they're actually smaller, and it really depends upon the printing technology. So as you say, hey, I'm going to use GRACOL as a reference, and I want to kind of match that down to my printing device, you might find that there's so much compression that's happening that there's just not enough accuracy, and things get very low in contrast, and you're not able to kind of maintain the same visual appearance between the original file and what's actually printed out. So there's a couple different compliance levels of G7. The first level is a G7 grayscale, and this is where you basically are just using the G7 process to curve the rip and bring it into tolerance. But it doesn't look at how the color matches. It doesn't look at anything more than just like, hey, are you able to hit the G7 within these metrics? G7 targeted, though, is actually designed for a printing press. So it's not designed for grand format. It is something that you would use commercial litho, or you could be using it on your web press, where there's very good data sets. And again, what you're doing is you're kind of building curves in your CTP system and trying to match the reference data of GRACOL or SWOP. But what most people will be using to achieve their compliance will be G7 color space. And what this is basically your G7 grayscale, so the first component, but then it's saying, hey, can we actually match GRACOL or SWOP 3? So usually when we do this, we try to find your best media and go from there to get our qualification. And then finally, there is this thing called G7 Extreme. There's a lot of people that kind of throw this around and not quite clear about it. But basically what it is kind of G7 grayscale, but with primaries that are larger and different than GRACOL or SWOP. So it's saying, hey, I'm implementing G7 here, but my color gamut is larger than GRACOL, because my inks got more fluorescence and stuff like that. So you're not actually using any color management. You're taking that you're taking that GRACOL separation and just pushing it out to the printing device. So if there's in the GRACOL separation of 50 cyan, it's going to print 50 cyan on the printing device. But since you've calibrated based upon G7 grayscale, it should be very, very close. So it's not going to be accurate color. You're going to look at it and go, well, that's not accurate, but it may be pleasing. And so here we have on the left-hand side, original GRACOL Sep, I should say. And then on the right-hand side, we have a GRACOL separation, same separation, but just printed through a G7 profile. And so you should be seeing a difference on your screen. Again, you'll see that, yep, there is a difference. I see there's a lot more saturation there. Is it a match? No, it's not designed to be a match. But the question is, would that be sufficient for your client? You know, if they didn't have that reference and they looked at that print, would they be like, yeah, I like that. It's got a lot more color to it. The color balance is pretty good, but does it match? No, does not match. But that may be more saleable. So this is, you know, what the original separation is. So, you know, it's a different approach. It's a way that you can say, hey, I want to, you know, take full advantage of the color gamut that I have on my printing device instead of squishing it down to kind of represent these offset ones because I feel that it's going to be a little more saleable. Most of the time we use this not so much for images, but for spot colors, where we want to kind of get a little bit more out of our vector objects that, you know, don't have any images in there, any bitmaps of sorts. So the benefits of G7 is you're going to be able to get a little more consistency across different printing technologies. Almost all the printing companies I go into now are having at least 2, usually 3 to 5 different printing technologies in their business. And so they need to have a system that allows them to get a more consistent match, not just by profiles, because I'm sure everyone has experience where, yes, we made our profiles, we've done our color match, we put the 2 prints down, and colorimetrically they look nice, but they don't have the same, one looks a little bit lower contrast, one just doesn't have the same oomph. And so you kind of say, well, what do I do in that instance? I mean, if I go pull curves in Photoshop, obviously that's going to change my color balance. If I go and try pull curves in the RIP software, that's going to change my color balance. So how do I get a little more snap out of that print that's lower contrast, even though the color is good? That's what G7 is very helpful for doing. It's trying to get the same visual contrast. Is it going to be perfect? No, absolutely not. It's not going to be perfect, but you're going to get a lot closer. I mean, if you put 2 references, I mean, if you put a reference and your print together and you look side by side and scrutinize it, of course you're always going to see a difference. But you got to kind of look and say, in the scheme of things, in the larger picture of sorts, you know, does this get me a little bit closer, and can I take that and then use my skills to improve that to be a little bit better, you know, knowing that, hey, it's not perfect, but I can take it from that point forward because it's close. Now, when you do the G7 process, you can also do a recalibration. That's not just 80 patches, which would be like, you know, 5% tints of CMYK, but up to 300 patches. And what this does is this allows us to have a lot more data to work with to kind of figure out where we need to make some adjustments in those curves. And if we're able to do the G7 prior to our profiles, we're able actually to kind of bring things back into line a lot tighter and improve the shelf life, if you will, of the profile that you create for that print process. So visual contrast is kind of the key component that I think a lot of people miss with the G7, and I wanted to kind of spend a little bit of time on that because you know, it's a very important aspect. If you say, hey, I'm going to print on gator foam, and then you're going to go print on some mesh, you know intuitively that they obviously going to have different you know, color gamuts and stuff like that. And if you use both profiles in the past for those type of materials, you see that, yes, you get similar greens that are coming out. I mean, they're not exactly the same saturation, but you'll see a bigger difference in terms of the visual contrast. And so, again, that's where G7 can help, is that, yes, we'll get a similar green. It's not going to be perfectly new, but it should have the same oomph, the same look as what you would have on, like, let's say, the gator foam. So this is pulled from the GRACOL, or G7 specification document. This is the patches that they recommend for, the neutral density that they recommend for GRACOL. And this is with a paper that has got, you know, 95 L-star on LAB. So on the top you see, you know, your neutral density. So if you grab your densitometer and you measured these different patches, you would be targeting these numbers of 0.54, which would be, of course, with the paper excluded from it. Whereas on the bottom, they're showing you L-star, which may be helpful for some other people, but it includes paper because there's no such thing as minus paper excluded for LAB readings. Here is a screenshot of a paper that was also 95, a little bit, it was not too far off from the reference, but you can see from here that when it measured the paper and measured, you know, where things were landing, that the CMY for paper extruded is not too far off from where we should have been. Let me back up a step here. So we were supposed to hit 0.25, 0.54, and 0.90, and we hit 0.25, 0.55, 0.95. So it's not too far off. And then on the bottom there, you see obviously your L-star readings on the bottom left corner there. So this is the standard G7 test form you can find. It's formatted for several different devices, which is nice. And you know, it's supported by lots of different packages out there. So it's great that it is a freely available chart that people can use and develop products around to support that. So a couple tools that are available to create G7 correction curves. One of the more popular ones is Chromix Curve 3. To kind of Print Control Pro, that's found a little bit more over in Europe, as well as the All-One Print Standardizer. So these are 3 products that you can use to create your G7 curves. For checking it, you have a little bit more products out there. There is Chromix Verify, to kind of rapid check, All-One Verify, Spot On Verify, and then the RIPs of EFI and GMG also, and CGS also has one too that I should put in there, and the Donnie. So these are different ones that you can check to see how your G7 is matching, and also how your color matches. So here we're seeing a before G7 correction. So on the top left corner, you'll see that we have our CMY MPDC, neutral print density curve. And what we want here is we want to see that the green and the red should be tracking on top of each other. So the CMY is not too far off. I mean, it's off, right? But it's not too far off. What the bigger problem is the K. See, there's a big discrepancy there with the K on the top right-hand corner. On the bottom left, you see after G7 correction that it's tracking much closer for CMY and for K. Is it perfect? No. Can we get it perfect? Probably. But right now, this is you know, passing, and so I tend to not try to overcorrect things, which means that you spend a lot of time just kind of finessing, because there's usually some more variation on the print process that you'll encounter. You may find that you're doing corrections that are unnecessary. Here's another screen capture from Curve 3 that shows you know, before session, and what we have here is you know, in the center, the shape of the CMYK. So this is your visual contrast, the shape of that CMY and the K curve. And so the CMY L star is orange, and then the K is black. And ideally, we want those to be kind of hovering around 0, but that may not be possible. And then on the bottom, we kind of see the errors in terms of gray balance. So not the shape, not how the visual contrast looks, but like how our gray balance is. And again, they kind of roll everything up to CMY into the green, and then you can see each individual channel of A and B on the bottom there. Kind of in the middle, you see under the G7 tab some results, and what those are telling us is like, is it going to pass or fail? Underneath that, you see G7 tolerances of average 1.5 and max of 3.0. So obviously with red, that tells us that we are not passing. So now, when we do a G7, you can see, okay, now we've got that much better. Again, is it perfect? Yeah, probably not. But it's much more improved, and we're able to, you know, meet within the tolerance. That's specified, you know, for the qualification. So you see towards on the bottom curve there, towards like around the 85 to 90% patch, things get a little hairy down there. So this is what happens, is that you can't really put a lot of correction into the shadows because of on a printing press it's wet trap, but on you know, a grand format device, there's usually a lot of ink coverage, sometimes additional inks. And so things get a little bit weird and a little bit squirrely down in the shadows. So to that effect, you have options when you're building the G7 curve as to how you want to feather off that correction. The default is 50%. So that means that it does a 100% gray balance correction up to 50%, and then after that it starts tapering off that type of correction. So there's less compensation that's happening. If you were to put the gray balance correction at 100%, it actually would only max out at 87.5. It won't go any higher. It will never ever allow you to go to 100% just because it's just too unstable down in those really, really dark tones. And your eye really can't see that. You know, you can see probably some tone around 85 or 90, but once you get past 90, it's very difficult to see any color because it's such a dark tone. So on the one that I showed you a little bit earlier, I probably took the gray balance correction and pushed it from 50% probably to 75, maybe 80%, just so I can get a little better correction in that shadows there. Because if I had left it at 50%, I probably would have had more error in that shadows and potentially would have failed the G7 qualification. Some new things for people that have been doing G7 for a little bit. There is a new method in the Curve 3 that allows you to target the native 300% patch. So typically, you're not going to find with a 300% patch, meaning 100% cyan, magenta, and yellow, and 0 black, that it will be neutral. But the legacy method assumes that it's going to be neutral. And so as it's doing its corrections, it's also kind of pulling curves to try to get you close to a 0A and a 0B. Whereas the relative or the native aim back, what it does is says, hey, you know, if you've got some color there, I'm not going to shift that. I'm going to basically, you know, do my corrections with that aim point in mind. But be careful because that may cause you to fail, you know, a qualification because you're now not targeting absolutes there. You're targeting more relative. So just be careful upon that. The next one is normalized high densities. It's designed really to kind of smooth out stuff, you know. They put several different smoothing algorithms into Curve 3, and this will make nicer curves in your whip. But again, you may find that it just will maybe not allow you to pass your qualification. You won't be within tolerance there. But this will potentially give you smoother curves in your CTP or your RIP product. Another method that you can also do is build profiles and then actually apply that data to P2P charts. So there's some techniques that we can use that allow us to get even more data. So instead of using just 300 patches, hey, we can use those 1,600 patches or more, and then use that and apply that to our P2P data to get our numbers instead of just taking straight 300 patches. So the files that you will download from ID Alliance, they are specifically designed a certain way to give a better accuracy for the software. So you don't want to try to build your own versions of this. You do not want to resize them. You want to leave it the way it is. It's going to be a problem if you scale it up or if you change anything on that file. They're made as a dither pattern. So if you zoom in on some of the patches, you'll see it's actually a checkerboard. But when you zoom out, it looks like one color. So that's what we're talking about there. Take your chart and rotate it to 180 degrees. You should have it in different orientations, and this will help in kind of dealing with any variability that is in the printing device. You know, I like to have at least you know, a couple files to average together, just to make sure. You know, it's like statistics. The more data, the better. So at some point, you know, measuring 50 charts ain't going to help you. But having just 2 data samples is probably not enough. So I like to usually take more. It really depends upon you know, the printing process and how even the coverage is across the sheet and all that sort of stuff. But you know, some other things that you should consider is try to you know, look into some products or methods to collect this data So you can statistically take all these data points that you gathered and be able to refine and improve the curves that you came up with initially. Because they may be okay, but they may not be ideal. So the more data you have, the better you can refine that. It also gives you kind of a way to look back in history and find out things that have happened, or you know, during the course of changing inks or papers or things of that sort. It allows you to kind of capture that and see if that was a problem or not. So Jim, let's jump into our last poll question.
Okay, 1 second there. I will pull that poll up. And the third poll that we have for everyone is the following. What are the most troublesome ways customers communicate color to you? So if you want to select one of the following, either one of the troublesome ways would be the file format, to give you a Microsoft Word Office or PDF document, the color mode, whether it be RGB, CMYK, or SPOT. A third option that could be troublesome is the customer supplied print or merchandise samples for you to match. And then the question is, if you have more than that, you say at least 2 of these options are problematic for my company. So if you have a chance, go ahead and weigh in with your opinion on this, and then we'll close the poll in just a second, and I'll share the results with everyone. If you have a quick second to go ahead and weigh in on that, we'd appreciate it. Okay, so here are the results, Dan. So 40% talk about the file format, and another 40% talk about the customer supplied print or merchandise samples, and then the result, the last 20% talk about at least 2 of these are problematic for the company.
Okay. Cool. All righty. Well, we're going to address some of those topics in the last presentation, but I wanted to jump into device link profiles, since that is kind of applicable to some of these things that we just asked about. Device links are kind of a special type of profile, and what it is basically 2 profiles smashed together. And so there's no longer a conversion through LAB. It's a really fast method, because there's all the calculations are done, and there's a lot of flexibility in the way that you can handle the conversion that you're baking together there. And so we're going to kind of go over that in the next section. But you know, the device links I wanted to bring up because it's something that's new and something that has just been added to the I1 profiler. And we're going to kind of address that, like I said, in the next presentation. So we're going to kind of go into like how to deal with you know, PMS colors, brand colors, you know, file types, things that revolve around kind of like how we kind of communicate color throughout the production. That's going to be on September 25th, so in about a month or so. We will be sending out, again, some more invites so people can register for that. So be on the lookout for that. And at this point, I think it's a good time to open up questions and answers.
Okay, sounds great. Thank you very much, Dan.
Sure.
The first question that we have here, and by the way, everyone else, the next question that we have here, and everyone can go ahead and log in any other questions that you might have. So as we're reading this first one, you can start typing in your questions. The first question had to do with the G7 and G7 to GRACOL, and I think you went over part of it. But the kernel of the question has to do with, why do I need to think in separation mode if I'm a grand or wide format printer using an inkjet printer?
Why do I need to think in separation? I'm not sure I understand the question.
Well, it's so the question as I read it is, you know, what is G7? What is G7 to GRACOL? What is SWOP? And why do I need to think in separation think if I'm a grand or wide format printer? like worrying about the color separation since they're not printing 4 colors, I suppose. That's kind of what I understood from it. I'm not,
Okay.
if I don't have a press that's using 4 different colors, then what?
Well, let me see if I can answer it this way. The person that asked the question, if they want to kind of follow up with another question or clarify, that would be good. But, you know, files are supplied usually as RGB or CMYK. Traditionally, everything's been CMYK. And if someone that doesn't know anything about what they're doing, they're just going to go Photoshop, load CMYK. So whatever their CMYK setup is will be what they're handing off to you. So they're probably separating to SWOP version 2, you know, US web coded, because that's just been the default for 10 years. If they're more sophisticated, they may have selected GRACOL, but what I wanted to show you there in one of those slides was that you can substitute GRACOL for SWOP, and you'll get a pretty good result. Is it going to be accurate? Probably not, but you see that it's pretty darn close. So that's your point of reference. That's what the customer has supplied. Your job now is to try to match that reference. So if your device is capable of having a larger gamut than GRACOL, then yeah, you can G7 it, create a profile, and then now you can match to GRACOL. If it's smaller than that, then you got to consider maybe I don't want to use color management. I just want to G7 it to try to get the full gamut of that and know that the color match is not going to be perfect, but it may be more pleasing for the customer. So it's a trade-off between accuracy and sellability.
Okay, very good. Another question. Do you have any tips on handling split inks?
Split inks. Now we're talking about like light inks. Is that what we're saying here? So like a light cyan and a light magenta.
Well, then the other question is, should RGB always be sent to split ink systems?
So
Yeah,
if you're talking about the lights, sorry, Jim?
It's CMYK, light cyan, light magenta. Yes, that's what.
Okay. So basically, the G7 aspect happens after you've done your what we would call transitions. So how you're blending those light cyan to dark cyan, how you're blending the light magenta to dark magenta. That's done prior to the G7. So depending upon your RIP, it will give you some tools to figure out what is the ideal separation method for blending those 2 inks. Once you've gone past that, then you go into your linearization, which just basically redistributes the tone so you have nice smooth gradients. And then finally you actually do your G7, which is refining those correction curves to get a better gray balance out of it. So G7 doesn't really deal with the transitions between like a light color and a dark color. That's handled more by the RIP.
Okay, good. And then a follow-up to that, should RGB always be sent to a split ink system?
I mean, you're going to get the best results because it has a larger gamut, typically with an RGB file, than a CMYK file would have. So yes, if you have the ability of taking an RGB and going directly to your output device and not mapping it through CMYK, like GRACOL or SWOP, then yes, you're going to get the best results that way. But know that if that customer comes back and says, hey, we want the same image on a different printing technology, you may not have exactly the same representation just because you are going to have different color games between those printing technologies and those medias. So if you foresee that customer or know that customer is going to need to print across different printing technologies, it might be better served to convert to like a CMYK color space to have a stable reference that you can use across your different printing technologies.
Okay, very good. Another question, does EFI XF 5.0 use the G7 method for calibration?
Not directly. So there are ways that you can implement the G7 correction in there, but they don't have a direct method. It'd be best if you kind of contact me offline and I can tell you how to do that. What their recommended method is to do a color match and use the reference of GRACOL or SWOP to get you to G7. And so with the EFI system, you set that up, and then you go through what they call profile optimization. And that really tunes that color match by printing out these ECI or ITA charts to achieve your G7 metric. So it does it through ICC profiles and color management. It doesn't necessarily do it by loading up correction curves.
Okay, good. And our final question for today is, there's a new GRACOL standard in 2013. When will this input profile be available?
Okay, so there's, the first GRACOL profile that they put out was in 2006. And they put out the data set there, and now, having 6 years elapsed, we have a lot more data and a lot more feedback, and they have updated the GRACOL profile with some minor, very minor adjustments to it. From the standpoint of a print buyer, they won't even notice it. They won't even see it. For most people, they won't even notice it. They won't even see it. When will that profile be available? Not exactly sure. It should be, I would say, I'm just guessing here, but I would say in the next month or two. I would go to idealliance.org. They would be the folks that would be publishing that and can also give you a more of a firm time frame as to when that profile would be available, or the data set.
Okay, very good. And then another follow-up question to that is, if you're really accurate with gray balancing, then theoretically you don't need an ICC. Is this correct?
No, I wouldn't say that. I mean, if you find that with one of the images I showed, is that G7 will get you there, and you'll have a pretty good color match. I mean, a pretty good visual match, but it's not going to be perfect. That's why you need color management. It really refines that thing to be more of an accurate. And so that's why I say G7 does not replace color management. It's just another portion of that. But there are times where you may say, hey, just because this media is just so low, it can't hold any ink. I can't get any, color gamut on it, that I can't use color management. Just putting any color management there is just going to destroy the image. So I need to basically print out a full gamut and have a pleasing look. G7 will help with that. So G7 does not replace color management. You will definitely need color management to get accuracy, but in certain instances where the medias are just too low contrast, color management may not help, and you may just find G7 would be useful. Okay,
very good. Well, Dan, we'd like to thank you very much for putting this presentation together for us. That will conclude our webinar for today. So first of all, thank you very much for your participation in our webinar, Dan.
Thank you.
And we also thank all of our attendees. We appreciate that. And we appreciate your prompt signing in, and also for your feedback and the questions responding to our polls. It made for a very lively discussion. And this will end our webinar for today.